To Mickey Study Circle channel. In this video, we shall see how to create the part model and also generate its orthographic projections using the Solid Edge 2023. So this is the part model that we are going to create in the 3D application of the Solid Edge 2023 and also generate its orthographic projections. So now before we create the 3D model, let us try to analyze the part that is given to us. So the observer is going to look in this direction, and it is very clearly seen that it is a rectangle of dimension 70 cross 50 having a height of 60 mm. So we can just divide this part into two. That is, the first is a rectangular base of 70 cross 50 with a height of 20 mm. And then on the top plane of this part, I can prepare this top view which is having a trapezoid on the front, and I can have a cutout of this trapezoid which is having a dimension of 40 cross 20. So this is the method in which we are going to create the 3D part. So now let us see how to create this 3D part using the software. And I'll be selecting the front plane. I'll select the line option. So let me draw the length of the part in the front view, which is equal to 70 mm. And then it is having a height of 20 mm. So let me draw a rectangle of 70 cross 20. You can go to the smart dimension, check out the dimensions, 70, and this is 20. So now we are going to select this profile and extrude this to the depth of 50 mm as given in the problem statement. So this is the front view. You can see that it is a rectangle of 70 cross 20. Now I will be selecting the top part of the rectangle that is created, and here I'm going to create the protrusion which is having a height of 40 mm. The total height is 60, but this rectangle base had a thickness of 20, so that is why the remaining part will be having a height of 40 mm. So now let me create that rectangle. So I'll be selecting the rectangle by 2 points. So let me place the first point here, the second point here, and then complete the rectangle. So now let me do the dimensioning of this rectangle. So this rectangle will have a width of 35. So we can just alter this width. Since it has taken the midpoint as the reference, you cannot alter this. So what I'll do is let me just delete this. I'll select the trim option here. So this is how you can delete the part that you've created. So now let me go for the rectangle option by 2 points. So do not take the midpoint. So just take any point below the midpoint and then draw a rectangle of arbitrary length. Now go for the smart dimension. So you can just see that it is 29.06. So change this to 35. So this completes the rectangle. So the length of the rectangle will be equal to 70. So no need to show that. It will become over dimensioning. So 35 is the width of the rectangle. So now let me select this rectangle and then extrude this rectangle to a height of 40 mm. Total height of the component is 60. So this is the front view. So now I'm going to create a trapezium in this plane and then have it as a cutout. So let me select the line option. So from the midpoint, I will be marking the depth of the trapezium, which is equal to 20 mm. And then from both the sides, it is 20 and 20 because the total length is 40 mm for the bottom of the trapezium. So this is equal to 20. So from here it is 20. So on both the sides it is 10. So let me join the upper and the lower ends of the trapezium, and then here again draw a line of 10 mm, then join it to the extreme end of the bottom line. So select the trim option and trim this line which was drawn to mark the depth of the trapezium. So now select this profile and then select the through all as the extend type and have it as a cutout. So this is the direction of the cutout. So this completes the creation of the 3D part. So now we can just see that this is the front view and this is the top view of the part and this is the right side view of the part. So you can just change this to visible and hidden edges, and then you can see the hidden edges in the transparent mode. So this is the creation of the 3D part. So as you can see, it is having a depth of 50 mm, total height of 60, and here it is having a rectangular flange on both the sides, which is equal to 35 mm, and this is a trapezium with a width of 35 and the bottom side measuring 40 and the top side measuring 20, and the total depth of this cutout is equal to 20 mm. So this completes the creation of the 3D part. So now we will save this. Now we can create the draft. So for that, select a new isometric draft, modify the sheet properties, right click on sheet 1, change the sheet to A4, untick show background, click on save defaults, click OK, fit the sheet to the screen. So in the home window, select view wizard and select the part model that you have saved recently. So now you can just see that the views are readily available. So change the scale to 1:1. So place the front view of the part, the top view, the corresponding left side view in the right profile plane. So this is the isometric part, which is not required for us. So we'll complete the orthographic projection by drawing the XY line and the X1, Y1 plane. So select a continuous line of thickness 0.13, draw the XY line, and then draw the X1, Y1 line. So from the point of intersection, draw a 45-degree line to get the side view. So now let me complete the front and the top projections. So these are the extreme edges, the projectors from the extreme edges. So in the top view, I'll be able to see only this complete surface. I'll not be able to see this cutout which is below this. So that is why it is showing as a dotted line. Okay, so then complete this. So these upper cutouts will be visible as dark lines. So the lower cutouts will be visible as invisible lines. And then draw the corresponding horizontal projectors. And then draw the horizontal projectors from the top view, and then from this point of intersection of the 45-degree line, draw a vertical projector, intersect the 45-degree line. So now you can just see that you have to adjust this side view to this extreme point. So for that, let me select the side view and select the move option, ensure the copy is off, select the extreme bottom left corner of the object and then place it on the end point of this projector. So you can just see that it is being adjusted accordingly. So we need to mark this. So this completes the orthographic projections. So now let us go to the annotation, change the font to Times New Roman and label the planes. So this plane is X, Y plane, and this is X1, Y1. And this is the front view, this is the top view, This is the left side view in the right profile plane. So select the leader option, select properties, change the color to black and click OK, and indicate the direction of the projectors. So this completes the projections, that is the front, top, and the left side view. So now we'll go for the smart dimension to indicate the dimensions. So here this is having a thickness of 20, and then the total height of the object is 60 mm and the width is 50. So all these dimensions should be shown in the side view. And then coming to the front view, so I can see this total length of the object, which is equal to 70, and this side dimension you've already shown here, so no need to show this, but here you have to show this dimension of 40 and 20, correct? And then this is having a dimension of 35. So since this is 20 and this total length is 70, so it is understood that this equal divisions will be equal to 25 and 25, that is 50 plus 20 is equal to 70. So no need to show the dimension again separately. So we'll assume that it is symmetric, and then it is 25 25 plus 20, which is equal to total length 70. So with this we complete the projections. So here also you can show the complete length of the object as it will be seen, and here this is 40, this edge, and this it is 20, which I've already shown in the front view. So this completes the generation of the orthographic projections of the isometric part that was created here. Front view, top, and the right side view. Thank you all for watching.